InSight isn't just a Mars mission, it's really a mission to the terrestrial planet interiors. So Mars is kind of the Goldilocks planets. It's not too big, it's not too small, it's just right. If it was too big, it would have retained a lot of activity and erased all the evidence that we're looking for. If it was too small, it never would have undergone the same processes that form the Earth, and so it's really just right.
Mars will give us this insight into early planet formation and early planetary processes.
Understanding the details of the structure of the interior of Mars will allow us to address questions of planetary formation that we've only been able to guess at before.
We are missing cold, hard data, and this is what this mission will provide.
The InSight mission is a geophysical mission to Mars. It's going to go to Mars and take its vital signs. It's going to take its heartbeat, the seismic activity of the planet.
So we're going to be doing that using a seismometer, a very high precision seismometer, using techniques that have been well developed on Earth to get the understanding of the crust, mantle, and core, and sort of the relationship between those.
It's going to take its temperature by measuring the thermal gradient of the surface, which tells how much heat is coming out.
We also have a heat flow probe, we call it HP cubed. And what that does is it's going to basically take the temperature of Mars, and from that it'll be able to understand what the thermal flux is over the course of a full Martian year.
And it's going to sort of measure its reflexes by looking at how the rotation wobbles with the tidal effects of the sun.
Our final experiment is called RISE, and that's going to be looking at basically the wobble of Mars to help understand what the core size may be in composition.
The Lockheed Martin flight system, our role is to build the aeroshell, the cruise stage, and the lander. All three of those have extremely high heritage from Phoenix.
20 meters, 50 meters, standing by for touchdown. Touchdown signal detected.
It's an advantage for us to use heritage designs because we're familiar with them, we've tested them, we've qualified them, they worked successfully on the surface of Mars. We have a really big head start.
A lot of things have come together to make it possible to learn a great deal about the interior of Mars from a seismometer.
So we have Kinest that's building our seismometer that's been under development for many, many years.
What it does is it just sits on the surface of Mars, and it's like a stethoscope. It listens to what's going on inside Mars.
On the HP cubed instrument, we have that being delivered to us from DLR. That also has been under development for many years.
And what this probe does is it penetrates into the subsurface up to 5 meters. On its way, it measures the thermal conductivity.
The basic mantra of our flight system design is low risk, and with that is low cost risk.
We've been to Mars before with the JPL Lockheed Martin team. We've been to the surface of Mars before successfully with Phoenix. We know how to operate the arm. The surface operations are much, much simpler than Phoenix. We're putting 2 instruments on the surface and then we're leaving them there with no ground-in-the-loop interaction, repetitive weekly uplink downlink sessions. We're just made to do this mission.
The heritage for InSight extends way past just the flight system and the hardware. It extends to the personnel, the processes, the tools that we've developed, and so forth.
With one spacecraft on a Discovery budget, we're really going to be able to do the science that for the last 20 years we thought would cost at least $1 billion to $1.5 billion and require 3 or 4 spacecraft.
We have very robust margins built into InSight. 50% margin on our instrument deployment timeline. We have 50% margin on our science data collection. We have 500% margin on our daily data volume. We're in good shape.
Well, I think this mission is going to generate a lot of excitement. We're already connecting to the public through Twitter, Facebook, and on the web. We're going to be working with educators to put Marsquake data in the hands of the kids to actually work with it as part of their earth science curriculum and get an angle on planetary science at the same time.
We've got the right expertise and knowledge to run this mission.
We're going to be ready for launch in 2016.
Within 6 months, we'll be landing on the planet and immediately bringing back our science.
It's going to be a great mission.